Hi guys, this is AP Chemistry 5.11 Catalysis. This is Dr. B. Your learning objective for this lecture is to be able to explain the relationship between the effect of a catalyst on a reaction and changes in the reaction mechanism. So a catalyst is a material that is used to help speed up a reaction but is not consumed by the reaction. Catalysts work in one of two ways. They alter the rate of reaction by changing the number of effective collisions, or they can provide an alternate chemical pathway that requires less energy. There are two different types. The first kind is a homogeneous, and the second is heterogeneous. A homogeneous catalyst is in the same phase as the reactants and mixes uniformly. This is usually seen in gas or aqueous phases, but you can have a heterogeneous catalyst and it's a different phase. So it could be a solid catalyst interacting with gaseous reactants. Excuse me. Typically, a homogeneous catalyst provides a different chemical pathway so that the activation for the rate determining step is lower. So there may be something to note for y'all. If it is a homogeneous catalyst, it will tell you. That means it's the same phase. And what they do is they alter the chemical pathway. So as you can see, there is, in this particular example, you have one pathway. Notice by adding a catalyst, though, your EA changes. I'll do this. This is my EA here. It didn't work. It did work. And then if I add a catalyst, notice how much lower. But there's two humps. But also notice how much lower the activation energy is. Also, as you can see in the other graph, if you can, like I said, either alter the chemical pathway by lowering the EA, or you can also decrease the number of collisions within a given energy. In this type of catalyst, catalysis, the catalyst is used in one or more of the elementary steps, but is regenerated by the end of the reaction. So that's kind of a key thing right here. Regenerated by the end of the reaction, thus it is not consumed and can be used to catalyze more reactants. Another type of catalyst speeds up the reaction by binding with one or more of the reactants. This allows the reactants to be in orientation that is more favorable for the reaction or now require a lower amount of energy to react. Some catalysts work by creating a new intermediate by forming a covalent bond between the catalyst and the reactant. This can occur in acid-base catalysis when a proton is transferred between the species. This results in new intermediates and therefore new elementary steps. In general, a heterogeneous catalyst speeds up the chemical reaction by altering the orientation of the molecules by providing an alternate reaction. So heterogeneous catalyst alters orientation of molecules. And homogeneous catalyst and a homogeneous catalyst provides a different chemical pathway. Okay. And what we mean by altering the orientation is that they do this by providing a usually solid surface that adsorbs, so that prefix ad, so it sticks to something, so absorbs to something, binds with the reactants, and then the reactants diffuse on the surface until they find another, and they react and finally the product desorbs from the surface into the gas phase. Modern cars are fitted with a catalytic converter that works in this method. They use a solid catalyst composed of platinum and rhodium to reduce nitrogen oxides in a redox reaction to form nitrogen and oxygen gas that are then desorbed. So the steps are adsorption, they react, and then desorption where they're kind of breaking bonds and forming new compounds. The rate of decomposition of hydrogen peroxide can be increased by adding a homogeneous catalyst. The reaction occurs in 2 steps seen below. Write the overall reaction, identify the catalyst, and then identify any intermediates. So let's see. So let me do it this way. So this is common on both sides. So is this. Now all I have left is the following. 2H2O2 aqueous produces 2H2O plus O2 gas. Identify the catalyst, identify the intermediates. So remember our definition of a catalyst in terms of a reaction mechanism. It is the catalyst is used in one of the elementary steps, but is regenerated by the end of the reaction. So that means it has to be present as a reactant, but in the end of the second mechanism, it actually will pop up again on the product side. So what does that mean? Our catalyst is then going to be that one. Our intermediate would be this one, because you can see that it is produced, but then it also pops up, it's used up again in the reactant, so it's no longer there present. Last slide. Ozone in the Earth's atmosphere serves to protect us from the potentially harmful UV rays from the sun. The following elementary steps describe one way that ozone is broken down in the upper atmosphere, creating a hole in the ozone layer. Interesting. So we have our first step, which is O3 plus NO produces NO2 plus O2, tells you it's a slow step. Second step, NO2 plus O produces NO plus O2. Write the overall reaction, identify the catalyst and intermediates. So NO is introduced as a reactant, then pops up in the products for the second one, so that means that that is considered my catalyst. We notice that NO2 is produced in the first step, but then is used up and is no longer present, so NO2 is my intermediate. My overall reaction is O3 gas plus O gas produces 2O2 gas. Alrighty, gentlemen, that's it. If you have any questions, please let me know. Thanks. Hit the like, subscribe, and blah, blah, blah. Bye.